In this video, I do not want to give you a generic .NET feature tour. There are plenty of videos that list new features one by one. That is useful, but not it's how most real migration decisions are made. In real projects, especially older business applications, the real question is much simpler. What would you actually adopt first if this system still had users, still made money, and still hurt every time the team touched it? This is the angle of the video. I have spent a lot of time around exactly this kind of systems. Older Microsoft stacks, long-lived enterprise applications, integration-heavy code bases, and migration work where you cannot just stop the business and rewrite everything from scratch. So I want to frame .NET 10 from that perspective. My thesis is that .NET 10 is a very good target for modernization. Not because it gives you permission to redesign your whole company, but because it gives you stable modern baseline. It is a LTS release. It brings better platform story. It lets you create safer boundaries around the parts you actually need improved first. So this is not a fantasy rewrite video. This is migration decision video. I am going to show what I would adapt now, what I would postpone, and how I would shape a small sample application that feels like something you could really build on top of. Let me start with the mistake I see most often in the migrations. Teams try to modernize everything at the same time. Most failed migrations do not fail because the team is lazy. They fail because the team becomes too ambitious too early. They want a new backend architecture, a new frontend, a new authentication story, a new database design, new infrastructure, maybe microservices. Maybe event-driven workflows, maybe a full domain rewrite. And on paper, all of that sounds impressive. But in practice, the migration becomes a second product that competes with the first one for time and money, attention and trust. My rule is very simple. Better seems before better diagrams. What I do being by that? I mean, I care more configuration being predictable than about drawing perfect architecture picture. I care more about dependency injection and testable service boundaries than about announcing a grand platform redesign. I care more about health checks, logs, predictable errors, and safe deployment than about renaming every folder into a textbook clean architecture layout on day one. A real migration becomes successful when the team can change one part of the system without accidentally breaking 5 others. That is the first win. Not elegance, not purity, not buzzwords, trust. So, I inherit a legacy .NET application. I do not ask, how do I make this look modern? I ask, where can I create a safer seam with the least risk and the highest return? That single question changes whole migration strategy. To make this concrete, let me show the kind of starting point I actually like to use for this discussion. For this video, I am not going to start from a perfect greenfield demo. I want to start from something boring, and boring is good. Imagine a small order management module inside an older business application. It has a controller or endpoint layer that grew over time. Some configuration is hidden in the old settings files or read through static helper methods. There is a direct database dependency somewhere in the middle. The import workflow is blocking and runs inside a request path. Errors are inconsistent. Some endpoints return custom JSON, for example, like here, leaks internal exception message to the caller, or no problem details. It returns to stack trace. So in the end, some exceptions are thrown, some just fail with odd ways. There is no clean contract for outside consumers. There may not even be a healthy endpoint. Now, one of that means the system is worthless. In fact, a lot of these systems are vulnerable to precisely because they survive. They carry business rules, special cases, old integrations, and years of operational knowledge. The problem is not that they exist. The problem is that every change feels expensive. That is why I like this kind of sample. Viewers can map into their own reality. They do not need a giant demo with 15 shiny subsystems. They need to see how ordinary module becomes safer and more modern without pretending the entire legacy estate disappearing overnight. So our sample is intentionally small, intentionally realistic, and intentionally close to kind of code that many teams already own. Once we agree on the starting point, the next question becomes the important one. What do I do adapt now? And what do I deliberately postpone? This is the most opinioned slide in this whole video. If I'm modernizing a legacy .NET application and I chose .NET 10 as target, here is what I adopt early. First, I adopt .NET 10 target itself because I want stable long-time support baseline. I do not want to do this work on a short-lived target if I can avoid it. I want the support window and I want the team to feel that the landing zone is durable. Second, I adopt type configuration and dependency injection cleanup. Hidden config and static access patterns make migrations fragile. Cleaning that up early gives me safer startup behavior, better testability, and fewer mystery failures. Third, I adopt a clean API boundary for a new slice. That might be minimal APIs, it might be controllers, but I want a modern HTTP surface with clear request and response contracts, validation, and predictable error shapes. Fourth, I adopt built-in OpenAPI generation, health checks, and a small test and CI story. This is where modernization becomes operationally meaningful. Fifth, I move long-running work like imports out of the request thread. If my workflow does not need to block client, I do not let it block the client. Now let me tell you what I postpone. I postpone the big front-end rewrite. I postpone broad database redesign. I postpone architecture teeter. I postpone microservices unless there is a proven operational reason. I postpone the dream version of the domain model. I postpone the giant security redesign unless current state is actively unsafe. And the reason is not that those topics are unimportant. The reason is sequencing. In migration work, timing is architecture. So with that strategy in mind, let me show the sample application I would actually build for this video. Sample app is called Northwind Migration Lab. I chose that name on purpose because I want it to feel familiar, small, and practical, not over-designed. This app is not trying to model an enterprise. It's just enough architecture to demonstrate a good migration path. Let's see our folders: source, tests, and samples. In the source, we can see 4 projects: API, application, domain, and infrastructure. In the tests, we can see Northwind unit test and integration tests. And under the samples legacy snapshot, the before side. Still here for comparison. Okay. The business story is simple. We have a small order management slice that needs to do 3 things well. Number 1, list and create orders. Create list. Number 2, import old order data from legacy edge. And number 3, expose a cleaner API surface that a future UI, another service, or even an AI assistant workflow could safely build on later. So those are the endpoints. The structure is also intentionally simple. I want an API project for endpoints and HTTP concerns, an application project for use cases and orchestration. Here's the application project. A domain project for the core entities and rules, import jobs, order item, an infrastructure project for EFCO, adapters, and background processing. Background service reads from the channel. Each job object gets its own scope. Then a test folder for unit and integration tests, like here. And here are the unit tests. And finally, a tiny legacy snapshot folder that keeps one ugly old style implementation around just for comparison. Here it is. We have the legacy import services with all those mistakes as comments. Legacy order controller, mistakes in the programs, yes. And of course the static DB helper class. The endpoints are also enough to make the story real. List orders, get one order by ID, and create an order. Trigger an import, like here. Expose health, and expose an OpenAPI document. The key design choices here: a legacy adapter scene. I do not delete the old edge on day 1. I wrap it. That's very real migration move. Now let us get into actual implementation order, because the order matters more than most people think. The first real implementation step is not fancy at all. It's configuration and dependency injection cleanup. This is usually where I start because it gives the fastest risk reduction for the least drama. In an older application, it's very common to see connection strings, environmental flags, import paths, or feature switches being pulled from the random places. Sometimes from static helper classes, sometimes from configuration managers, sometimes directly inside controllers, sometimes half-cached in a single like patterns that nobody fully trusts. Look at here. Magic keys, no type safety, no startup validation. Then I clean up the obvious service boundaries. For example, instead of a controller talking directly to the database helper and a file importer, a static clock utility, I inject interfaces with clear responsibilities. Maybe I order a repository. Look at here. Dependencies are injected. Behavior is testable against a real DB. No static helpers, no data table. Maybe I legacy order import source. Maybe I clock. Maybe I import queue. Like here. This is not a glamorous work, but this is where migration becomes testable. Once dependencies are explicit, you can isolate the behavior. Once behavior is isolated, you can refactor with less fear. And once fear goes down, delivery speed usually goes up. Look at this required attribute. Data annotations, type properties, one class, all the database settings validated at startup. Look at here. If the settings is missing, the app refuses to start immediately, not meet requests. Infrastructure service extensions. Look at that scoped. Repositories, read queries, services, explicit interfaces, explicit registrations. Now every dependency is testable. So if you only remember one thing from this slide, remember this. Typed options and DI are not cleanup tasks. They are migration accelerators. Once configuration and dependencies are under control, I can create a modern API surface that starts paying off immediately. This is where .NET 10 starts giving us very visible value. For the new slice, I want a small, modern HTTP surface with predictable contracts. I am not trying to migrate every endpoint in the old system. I am creating one clean slice that is easier to consume, easier to test, and easier to extend. In .NET 10, I can lean on the platform more directly. ASP.NET Core has built-in OpenAPI support, and I can expose runtime document with add OpenAPI. Here it is. And map OpenAPI. Here it is. Generated OpenAPI document. If I want the document in YAML, I can map it with YAML route. This is a small thing, but it's useful in real terms and teams because contracts stop living only in code or in somebody's memory. Validation is also more interesting now. .NET 10 moved the unified validation API into Microsoft Extensions validation, and minimal APIs can use add validation, so the runtime can automatically validate incoming data and return a 400 response when payload is wrong. That means less custom defensive boilerplate and more consistency at the edge. Let's go to the routes, order endpoints. Look at here. Results at created at route get ordered by ID. So 201 plus location header and standard REST. Let's go to the terminal, and with the command .NET run project source Northwind API, it will run the application on the port 5269. So in demo, I will register validation, map the new order endpoints, return problem details for known failures, and then show one bad request on purpose. I want the audience to see the difference between ad hoc legacy error and a clean, predictable response. So since we have started the application on the port 5269, let's open a browser. In the browser, let's go to localhost 5269 / OpenAPI / v1 YAML. As you can see, the generated YAML says no extra tooling, no Swagger UI package needed. Everything is here listed. Order item DTOs, patterns, HTTP validation problem details. Let's go back to terminal, and in the terminal, let's trigger the API orders with the customer ID of nothing and items with nothing. As you can see, the remote server returned an error, 400 bad requests. This was intentional. Predictable shape, no raw exception leaking out. But right now, if we go with post orders with an actual customer ID for customer 1, we will see 201. Same endpoint, right input, clean contract. Let's go back to logs. As you can see, a database command has been triggered, and it inserts into orders what we have posted. According to logs, there is no problem. Let's select Northwind Migration Lab database in the Microsoft SQL Management Studio and check if it's actually created or not. Yes, look at this ID, 350. In terminal, it's saying that it's created, so we validated it's created right now in the database too. Because once your API contract becomes predictable, front-end work gets easier, automation gets easier, documentation gets easier, and later AI integration gets easier too. Modernization is not just about newer code, it's about reducing the surprise. Now the API edge is cleaner. The next question is the data access. And this is where I think teams often become too ideological. Here's my view on data access during migration. EF Core is a tool, not a religion. For this sample, I'm happy to use EF Core 10 for the normal path. Creating an order, loading a straightforward aggregate, writing the common business path, those are good places to benefit from EF Core because it keeps code maintainable and expressive. Let's look at async, DB orders add and save changes. EF Core for the right path, clean and expressive. Let's go to order configuration. Look at here, private backing field, EF Core still tracks it, no public setter on the collection. But I do not force every existing query through link just because the project now targets a newer framework. If I already have one hot read path, a reporting query, or some ugly proven SQL that is central to performance, I'm completely fine keeping that as direct SQL behind an application boundary. Look, infrastructure query, order read queries. Look at this database connection. No EF, no extra package. Hot read path stays as direct SQL. No RM overhead, no magic. EF Core for writes, direct SQL for reads. Both live comfortably in the same project. Look at here, and it reads. The migration goal is not to make every line look fashionable. The goal is to preserve known good behavior while making the future change safer. So what I demonstrate here is a mixed but disciplined approach. EF Core for everyday transaction path, direct SQL, or a lightweight data access path for the places that are already performance sensitive or shape specific. And I will say one more thing very clearly. Query discipline matters more than ORM reference. I care about pagination, predictable projections, avoiding wasteful graph loading, understanding the generated SQL, and putting indexes where the real workloads needs them. If everyone takes that message away, this slide is a success. Once request path and the data path are under control, I want to remove one more major source of operational pain, blocking work. This is the slide where modernization becomes operationally real. If the old system has an important endpoint that does heavy work inside the request, I almost always try to change that early. Let's go to the import channel CS. Look, channel create unbounded. In process queue, no broker needed. Enqueue returns immediately. The client gets 202 right away. Let's go to the import worker. Not because background processing is trendy, but because blocking work inside request threads is one of the easiest ways to create slow and fragile behavior. So in this sample, I will change import flow from the do the whole thing now into accept the request, create an import job, queue the work, and let a background worker process it. That one move usually improves responsiveness, resilience, and observability at the same time. Look at here the background service. Job starts and job completes or fails. State transitions. Worker runs on a background thread, request path is free, and we don't cancel the failure record. Let's go to the terminal and API is still running. Let's validate that. And let's make a call to the API import orders. A post request, the job ID. Look, we have an accepted job ID here. Then we go back to terminal and check and watch for the worker log lines. Right now here, look, it's here. Import job complete 202. Immediately, work happens in the background. Then I add the trust building basics. A health endpoint, 1 or 2 integration smoke tests, maybe a simple create order test and a health test. And then very small CI pipeline that restores, builds, runs tests, and maybe emits the OpenAPI artifact. Let's open a browser and let's go to localhost to our YAML back to again, and let's change the OpenAPI query string to health Z. So right now we can see status is healthy, SQL Server healthy. One endpoint, operation teams can write this into any monitoring tool. Let's go back to Visual Studio. Let's go to tests. Let's go to the order endpoint tests. Look, post order returns to a 1 with location when valid, a body, a response, and the status. One endpoint, real HTTP, real database, isolated per test class, no mocks needed here. Let's go back to the terminal. Here we can trigger that test. here in the migration lab folder where the Northwind migration lab solution file is living. Let's run the test. As you can see, the tests are, the restore is complete and compiling. Yep, test summary. 26 of the tests are succeeded. Let's go back to Visual Studio, go inside the secret GitHub folder and workflows CI YAML. Look, check out this. Setup.NET 10, restore build, unit test, and upload TRX. 26 unit tests, no SQL Server needed in CI. Integration tests are tagged and excluded. Every push to main gets this automatically. Notice how ordinary this sounds. That's the point. A lot of modernization effort gets wasted on dramatic diagrams while the actual runtime trust story remains weak. For me, the question is always this: is the new slice easier to trust in production than the old slice? The answer is yes, because the failures are clear, health is visible, tests are exists, imports are no longer blocking, and the building pipeline is repeatable. Then the migration is already creating real value. That is a much better milestone than we created a cleaner architecture folder. At this point, everyone has seen the strategy, the sample, and the implementation order. So let me close by showing how I would package this as a complete video. So if I were recording this as a YouTube episode, the structure would be very simple. I would open by saying this is not a .NET feature roundup. It's a migration priorities video. Then I would establish the boring legacy baseline because that is what makes the rest relatable. Then I would do opinion part, what I adapt now, what I postpone. Then I would walk through the sample application shape and the implementation order, configuration and DI first, API boundary next, query discipline after that, then workers, health, tests, CI. And the final takeaway for the audience would be this: if you are migrating to .NET 10, do not start by trying to impress people. Start making one slice of the system safer. Target the long-time support release. Create better themes. Make configuration explicit. Add validation and documentation. Move long-running work off the request thread. Add health and tests. Add only after that decide which larger redesigns are truly worth doing. That is how I would actually adapt .NET 10 in a real project. And if this video lands well, the follow-up videos almost write themselves. EF core query tuning in the same sample, CI/CD for this app, open telemetry and structured logging. Even how to hide an old VCF or legacy service behind a cleaner adapter. This is much stronger content series than a one-off feature list. If you want, next step after this can be actual sample implementation, where we build Northwind migration lab step by step and turn this migration strategy into working code. Also, if you did like this content, you can go to my GitHub Northwind Migration Lab repo. You can see all the code that I show in this video. Clone it, test it on your local. So if you like this video, please hit subscribe and like this video. See you in the next video.